Hello, John Webster, otherwise known as Dr. Cool. We at Cool Grind have put together a video for you, fairly short, which is describing our innovative products that we manufacture. We make a lot of generic nozzles, which are fine if you have one port and you only have a narrow grinding wheel. But when you've got a complicated shape like an aerospace grinding wheel, or you need to put multiple nozzles on one port, we've got a range of innovative products to display to you today. I hope you enjoy it. Modular hose nozzles can be increased or decreased in length to suit the distance from the manifold to the grinding zone. One example is the LocLine, the one in the middle at the top, a classic design and used all over the world, a very innovative design. The top left and the right hand side, I call them the big nut nozzles because you need huge wrenches to be able to tighten up each individual element. And one issue is that when you tighten up the element, the nozzle rotates with it. So it's a little bit difficult to aim, but they run at high pressure if you have high pressure on the machine. And grind machines typically only have up to 100 psi in 99% of cases. The design called Grind-Loc at the bottom there on the left is using the LocLine elements and the ball size, but it integrates clamps and coherent jet nozzles into that design. So you've got a higher pressure rating, you've got a better quality jet than the LocLine, but it's the same family and can be interchangeable. Grinding machines tend to run at higher pressure than machining processes. So when you're trying to use LocLine on these machines, if you have a pressure, say, of 4 bar at the manifold, then you can have issues with the nozzle moving, or in the case of the example here, the nozzle came off. If we lowered the pressure to 2 bar pressure, you'll see what happens, and that's about 30 psi, and the nozzle tends to move, but it doesn't come off the machine. You can get clamps for LocLine nozzles, which does significantly help the situation. Here we're testing now at 1 bar pressure, which is about 15 psi. And the nozzle does stay in position, so that's great, but at 4 bar there would be an issue unless you use clamps. The next product here is Grind-Loc, run at 7 bar, which is about 100 psi. And you see the nozzle does not move, it stays in position. But it's a smaller nozzle, so a bit of hard plumbing really helps. This slide shows the range of nozzles available within the Grind-Loc Modular Hose system. There are now more nozzles than shown because we invent new products all the time. We've got a much bigger, wider nozzle, which is not included there. But you can see it's very modular, just like the LocLine. When rigging nozzles onto a grinding machine, it's difficult to know exactly how many parts you need. And the Grind-Loc Kits allow you to have a lot of extra pieces there. This is a 15 nozzle kit. It has many adapters and steel pipes that can be put into a pipe bender, various clamps and threaded ends that you can go into the manifold, telescopes that allow adjustment for wheel wear, etc. And this is a much more convenient way to be in front of the machine and invent your solution. This slide shows the before and after on a grinding machine. On the left-hand side, you can see LocLine coming out of the 6 ports. The nozzles were taken off by the customer because they created too much pressure and the nozzles moved out of the way. And the first joint was the one that was always moving because of the greatest torque as a cantilever. In the middle view, you can see I've got hard plumbing and long extension tubes that go into the ports because In many machines, the wheel is in a very similar position and just needs fine tuning of the jets to hit the sweet spot on the wheel. So, and the right hand view as well, you can see that, and we've got telescopes as well, so if the wheel pack changes and the spacers are changing, you can just push the nozzles in or out and put them out and get them in the right place. But it just shows you, and the stiffness as well from the hard plumbing makes a huge difference to the pressure rating. Piranha is a high pressure version of Grind-Loc. You've got special metal clamps to give high pressure clamping pressure, and you've got up to 200 psi is available from the jet before it will move out of position. There's various nozzles that can be integrated into the Piranha system. They should have metal balls, and that's one of the features of the Piranha, is that the plastic black couplings onto metal balls gives that high friction that gives you the higher pressure capability. Here you can see that a pair of circlip pliers are used to assemble the clamps, much easier than using your hands, and then the screw goes in. It's a torque screwdriver, and then it's ready, and it's ready to fire up. You can see a very neat arrangement and very strong. The donut system is a sub-manifold system. You can see it fitted to a cylindrical grinder. We have the hose coming in from the left into a right-angled elbow and into the donut assembly. There's an adjuster arm in this particular case to compensate for wheel wear. The donut manifold system is based on a ported tube, the black item there in the photograph. That connects to a coolant port on the machine, and you can get multiple nozzles from a single port. You see here you have a spacer, then you might have an active donut with a nozzle, then another spacer, then another nozzle, another spacer, another nozzle, and at the very end the end cap seals and holds everything together and stops rotation. The donuts have an internal annulus that allows flow from any direction of the ported tube relative to the nozzle. You see 3 different types of nozzles in this picture here, which are coherent jet nozzles, and you can adjust the spacing with half donuts and quarter donuts to get them exactly in line with the grinding wheel. We saw earlier the air barrier influencing the coolant delivery on centerless grinders because they're open machines. The modular centerless nozzles made by Grind are very frugal, so we don't have a high flow rate, but it increases the pressure from the pump to break the air barrier. And you can see here the fan-shaped jets, and they work very effectively and reduce the wheel wear and also the regulating wheel wear.
Hello everyone, Webster here for Grind. Today I'm outside in the cold Connecticut weather. I got the mobile flow testing tool here because I'm flow testing our centerless OD grinding nozzle. Now let me bring it in close so you can see it. This is our 20-inch version. These can go up to 24 inches and also will go down to 6 inches. And the cool thing about this one, we got the flat fan nozzles here, but what we do is we actually position them, we turn them slightly so that they do not interfere with themselves. That way you've got nice coolant coverage on the entire wheel. So let me thread this on the flow testing tool here, like so. Very simply, thread it on. And now this is going to be positioned so that the jet will flow towards the camera, so I'm going to have to move that camera, or else it's going to be absolutely soaked, and I don't want to buy a new camera. Alright, I like the way that's nice and tight. So let me bring the camera in nice and close. I'll do an overhead shot so you can see those jets. So as you can see from that overhead shot, the jets really don't interfere with one another, which gives you excellent coverage on your grinding wheel. Now we tested that at 60 psi, and that's just from the pressure from the hose.
The Slide-Loc system has similar attributes to the donut system. You can adjust the axial position of the nozzles relative to the wheel, but with Slide-Loc you can make much smaller changes. And it's also very easy to remove nozzles and add new nozzles. And the other advantage is the manifold that controls the flow to each nozzle can be in a different position away from the grinding wheel. So it's a little bit more versatile. This is a close-up of the Slide-Loc system showing how many nozzles can be fitted onto a keyed shaft. I say a keyed shaft because you've got a set screw on these Slide-Locs that allow you to lock the rotation of the Slide-Loc relative to that shaft, so they don't move around when the pressure comes on. But you can back off the set screw if you want to have rotation, then you tighten up the knob. And you see here multiple types of nozzles, there's flat and round. There's an adapter here for one particular machine, but we have many other adapters where we can put into the existing adjusting arm, and then we can create that keyed shaft ready for the Slide-Loc. Chamber-based nozzles are useful for surface grinding and creep feed grinding applications where the width of the wheel can change. We can select nozzles or deselect. We can plug nozzles and just have active ones. Whatever you need, you can configure an approximate profile of the jets. The top left fits onto a Blom grinder with plungers to turn the flow on and off. The top right are for gear grinders to do the flanks of the gear. Then we have a generic creep feed nozzle at the bottom left where you can configure an approximate profile there. And the one on the bottom right is for master link for a tracked vehicle. Our chamber nozzles for cylindrical and surface grinding can incorporate on-off switches. The more pressure, the more they seal. The one on the far left in this view is always on because it's the one inboard for the flange of the wheel. And as you can see, very effective. Needle nozzles were initially developed in Germany, come out of the University of Aachen, and they rely on individual hypodermic quality stainless steel tubes configured into some sort of end plate to create a profile of jets. They give a pretty good jet. And if you look at the picture here, we have the standard design here. We call it the Flex Standard. Our Flex system has an array of holes, so you can just put the needles where you need them to be able to mimic the shape of the wheel, and you can use balls to seal up the holes. The one there called the Flex Sidewall is particular to aerospace applications where you have the flex design for the needles, but you can add in rotary nozzles, flat nozzles, that will hit the sidewalls of the wheel where you have areas of high heat and sidewalls, for example. The needles on their own cannot easily control the heat on a sidewall, hence this hybrid system called the Flex Sidewall. This tutorial shows the assembly of the Hypo-Grind Flex nozzle for surface grinding and creep feed grinding. The end plate where we're assembling the needles into has a matrix of holes. It's a staggered array, and here you see we're putting the final needle in of a straight nozzle, but it could be a profile nozzle, and sealing the additional hole with a Delrin ball. The end plate can be locked with a special thin plate So if you drop or you accidentally knock the end plate and a needle would normally be pushed in again, then this will stop that happening, make it a much stiffer setup if you make one dedicated for a particular wheel form. The end plate with the locking plate is then assembled to the chamber. This design has many screws for manual connection. There are other designs which are much quicker for you to assemble that could be incorporated. So you'd have a common chamber that stays on the machine, and the nozzle jets will be configured to the shape of the wheel and the offset of the wheel. So choose the widest possible wheel profile to choose the correct flex end plate. The quick disconnect system is perfect for cutting tool grinding machines, especially when there's small batch sizes to be ground. We have a receptacle, like an airline fitting, where you pull the sleeve back to release the nozzle. There is a slot cut into that receptacle where a key on the nozzle will engage to stop rotation. So each of these ports can have a gashing nozzle, it could have a fluting nozzle, you can swap them around if the wheel pack's reversed. You can also plug different outputs here. There's a plug that goes in, and there's various designs, and you'll see in the next slide configured on the machine. This machine has 3 coolant ports on each side of the spindle. You have wheels on each side, and in this particular case we have on the right hand side we have a splitter that goes from a single port into 2 nozzles, and both of those nozzles are for fluting. Plenty of adjustment and rotation. The middle port is plugged, so we're not getting any loss of pressure from that zone. And the left hand port has 2 nozzles for grinding on the OD cup wheel. So that all can be removed within seconds and replaced with different nozzles.
Hello everybody, Nick Webster here at Grind. We're going to be doing some flow testing. We're flow testing the Hypo-Grind needle nozzle. Now we've got 2 versions of this needle nozzle. It's we got the 1.5" and we got the 2". We're going to be flow testing the 2" version today, because that has to go out to a customer. We want to make sure it's got the right coolant flow and it meets the requirements that we set, and the customer gets the best product. Now that needle nozzle is this one right here. Alright, so let me give you a close-up of this Hypo-Grind needle nozzle. You can see here we've got 12 needles for coverage of 2 inches. You've also got a swivel ball here for any adjustments that need to be made while this is on the machine. Now this nozzle is compatible with our 1/2" nozzle tube system. Now we've got a female thread here that's 7/8 20. We have adapters that will convert this into a 3/8 male. Now this is also a compression fitting, so once you get this nozzle in the position that you need it, tighten it up, lock it into place. Don't mind the dirty hands, this is my 50th flow test today. Tighten it up real nice. There you go. And that's not going to move on you. So let's get this bad boy on the flow testing tool. Like so. Righty tighty, lefty loosey. Remember that. Make sure that's pointing at that drain, you know, because if these 12 jets are spraying somewhere else, it's going to be a mess. Alright, so let me tighten this up. I got my wrench here. Make sure it doesn't move on me. Alright, I like that. Let's do this. Let's see what this looks like. So there you have it. Hypo-Grind needle nozzle. Flow tested and approved. I'm happy with the results. I didn't see any blockage. Now really what I'm looking for is any blockage in any one of these jets. All 12 had good flow. So we're going to pack this up and ship this out to the customer. Thanks for watching, everybody.
A modified laser bore sighter is used to aim the nozzles on the grinding machine. It's a lot quicker to do it dry with the laser than to start the wheel, clean the window, etc. So it's a lot less messy. And minimization of flow rate is obviously more achievable when you get the jet in the right position, and also lower scrap rate because the first part is perfect. And your part precision can also be increased by the minimization of the flow rate. The cool grind nozzles are very precise, so the laser gives exactly the position where the jet would go. In this video we have a grinding wheel which is about 6 feet away from the nozzle. The nozzle is one of our coherent jet round designs with the fire hose profile. The laser fits on the outside of the nozzle, and then we switch the coolant on. You can see, very precise, that's 6 feet away. It hits exactly the middle of the wheel. Please check out our website, shown there, cool-grind.com, or give us a call at the 860-208-5196 number. We'd love to help you. Thank you.